Okay, so we are not going to get into IMS DB straight away. Okay, we are going to see how IMS DB developed. Okay, so people thought this is the better structure, and let's see how they thought and why they thought it's a better structure. So we have to understand the background. Then only we'll come to know. I mean about the fundamentals of IMS. Once you are good at fundamentals, you can write any programs. Okay, basically, the structure is very complex, and if you understand the structure better, then it's going to be very easy. Okay, it's going to be very easy cake. Okay, I have trained more than 30, 40 batches in India. Okay, in fact, I've done the large, with most number of batches in India for IMS DB and IMS DC. Okay, in my experience, if you understand the fundamentals, in first three sessions itself, you'll be able to know, I mean, work with IMS DB effectively. I've seen a lot of freshers. Okay, I have done this in my trainings. Let's start with some data storage and management concepts, which are how to be how to understand. Okay. So in this chapter, we are going to see all these how IMSDB got developed, okay, some evolution. Okay, as you are already aware, so we had only so PS files and VSAM files. Okay, PS files and VSAM files. Okay. That's my- So we have PS and files and VSAM files. Then what IBM did, IBM brought a database called IMS DB. Okay, in 1960s. Primarily, it was used for Apollo mission. Okay, to sending satellite to moon, and it's a successful mission by US. So it was primarily used by NASA. Okay, NASA used IMS DB to store data, and they primarily used for the mission of sending satellite to moon in 1960. Then it came to market for commercial purpose, and people and many companies came forward. Okay, many banks came forward, many airlines came forward, and similarly many telecom companies came forward. Okay, so those companies they came forward and started purchasing this database and I mean storing the data in database. And you are already aware, right? The why database is required. It has a lot of advantages when compared to file management systems. We'll probably quickly see what are the advantages of a database. Okay, because probably one or two you might have, I mean, not come across. Okay, then they will just quickly see what's an advantage of database also. So as a competition, we had another database, IDMS, Integrated Database Management System. It's called, it's part of network database. Okay, what is IMS structure is called? Anybody? Okay, it's an inverted tree structure. Okay, it's a hierarchical structure or inverted tree structure. Okay, it will be like this. What about IDMS? So IDMS is network database. Okay, for example, in inverted tree structure, which IMS DB is designed, okay, one child will have only one parent. Okay, but in here, say one this is one child, this will have multiple parents. It's a very complex structure. The network. So there are three databases in mainframe. One is IMS, second one is IDMS, the third one is DB2. If you take probably 100% of mainframe projects, 85% will be using DB2. Okay, and probably some 15% will be using IMS. 1 or 2% will be IDMS. And people who are using IMS will also have DB2 as well. Okay, you will be seeing both the databases in the system. Okay, similarly, whoever is having IDMS, they will have DB2 as well. So in 1960s, it was flourishing. Okay, for another 20 years. Okay, IMS DB was used. Then IBM brought another database, DB2. Okay, they brought in 1980s, early 1980s. I think 1982. So DB2 is RDBMS, as you're already aware. Okay, so in fact, Oracle was introduced in 1979, and DB2 was introduced in 1982. So people started purchasing DB2, which is an advanced database management system, very easy to use, and it's straightforward structure, rows and columns. So they purchased DB2. So if you take any big companies, which automated their software in 1960s or 70s, they would have used IMS, and after 1980s they would have purchased the DB2 software as well. So both the data will be there in both the database. Okay, data will be there in both the database. We'll So as and when the training goes, at the end we'll discuss all complex scenarios. Okay, there are some good scenarios which Darshana has messaged me. He wants to learn this and when good concepts. Similarly, others also can come in at the end of the training. We can very well see some advanced concepts. Okay, I'll tell you some advanced concepts. If you come across something, you can let me know. And if I know, I'm aware, we can very well see. So I'm not going to discuss about batch processing and online processing, but at least to some extent. So IMS DB is used in both batch processing and online processing. Okay, IMS DB is used in both batch and online. And in online processing, it is used in two online transaction processing platforms. One is CICS. Okay, as you're already aware, CICS, Customer Information Control System, is one online transaction processing platform in which IMS DB can be used. Another platform is IMS DC. So Information Management System, Data Communication. In fact, if you take IMS DC, it will use IMS DB for sure. Okay. And in fact, so it depends on the design of the project. Okay. So when IMS DB came into existence in 1960s, IMS DC also was there. Okay, for online OLTP, they bought IMS DC, and they bought data for our database. They bought IMS shortcut writing application and storing data in IMS DB. For transactions, they used IMS DC. Okay. And again, the companies bought DB2. Some companies will have CACS as well. Okay, again, it will be based on the design of the application, design of the project. They will have both CACS and IMS DC. They might have linked these two. There are many links. You can transfer data across these two platforms. Okay, and IMS DB can be used both in CICS and IMS DC environment. Similarly, DB2 can be used in both CICS and IMS DC environment. So if you are using in different environments, so then you have to have some extra caution. Okay, for example, if you want to have sync point, okay, there's something called sync point or commit. All these you have to just think and do properly. So this is how IMS DB came into existence. It's an inverted tree structure or hierarchical structure. Okay, it's a complex structure. It was introduced in 1960s. Okay, now let's see some architecture. Okay, what was architecture or data architecture which was used in very olden days? For example, if you take olden days, so in in olden days, 60s or 70s, software was very expensive. Okay, software was very expensive. So what they did, since it was very expensive, they cannot, develop the entire all the software in one shot. Instead, what they did, they created one application at a time. Okay, one application at a time. Because it's expensive. For example, if you take a big company, they'll do the billing application, which is very troublesome application. They'll automate and create an application or software. Then they would have automated some other application, say ordering application or shipping application. Okay, so application was created one at a time from 60s, 50s, 60s, 70s onwards. That's the reason it's very complex nowadays, and we need a lot of people to support. But in today's world, if you want to create open a business, you can buy a software and configure the software. Otherwise, you can create an entire software in one shot. Unlike in olden days, since we had one application at a time, it's called application-oriented approach. Okay, application-oriented approach. In application-oriented approach, application evolved one at a time. Okay, and we had customized database or data files or DBs for each application. Every application had a file system or database. Just see here. So if you understand this, you will understand very clearly how IMS DB came into existence. And again, if you know the fundamentals of how it came into existence, how if you visualize how data can be stored, then it's very easy how data can be retrieved. Okay, the main challenge is how data can be retrieved and also effectively. For that, you have to understand how it is, how it was really developed and how data can sit into the database. That's the reason I'm just covering all these. You see, application-oriented approach. It was like this. So we have one application called payroll. First, let us say the automated payroll system, then HR, and then medical. So payroll system had their own file or database. Okay, their own individual file or database. Similarly, every application or database had their own file system and data. Because this was the approach followed in any big project, big company in 60s, 70s, 80s, or if you take any mainframe project. Okay, they followed application-oriented approach. Can you see any drawbacks in this approach? Can you see any drawbacks in this approach? So we have payroll application, HR application, and medical application. Can you see any drawback? SSN name and address is repeating. So what is this called? Okay, data repetition or data redundancy. If data is repeating, what is the problem? Okay, space. In olden days, space was a challenge. Okay, if you take a 24 MB data, it was like a big bureau. Okay, but now 1 TB can be you can hold in a hand. But space is one issue. Is there any other issue? Data integrity. What do you mean data integrity? Data integrity means if you're so here it's like an orphan record. Okay, what are you saying is you're deleting in one place and you're not leaving in another place. Okay, for example, take Amazon. Amazon has say item database and product. Say order database. So let's open this. Amazon has item database and order database and say tracking database. Suppose they stopped selling iPhone 3. Okay, iPhone 3 is the first iPhone they introduced in 2008, I think. Okay, so assume iPhone 3 is removed from tracking in our database. They have, but they didn't fail to remove from item database. Okay, so it's like an orphan record, but it is never used at all. So even though since it's never used, we can't say we have more data integrity issues, but it's unnecessary. Okay, but to some extent, it's a data integrity. Data integrity means you can't trust the data. Any other suppose let us see I have it's my name. Okay, I have say currently I'm in Chennai. So you told about an example for uh, deletion, right? Now let us see. Assume I'm going to Bangalore. I'm informing the company I'm going to Bangalore. Okay, I'm telling the HR. So what HR did? Okay, since I said Bangalore, HR has changed my address to Bangalore. So remember, it's a okay. They are also HR and payroll are together. Okay, that's change in payroll database as well. They haven't informed the medical department. They haven't informed. They forgot to inform because manual error can exist. Since they haven't informed the medical department, my address is going to point to old address in medical department. If medical department is going to send a policy, it will go to my old address. Okay, it is not going to come to the new address. So if you have same data repeating in multiple places, it's very difficult to maintain. If you want to change, you have to change in all the places. Again, effort wise, it's high. Okay, if you want to change, you have to change in all places. Effort wise, high. And again, you said so we have storage issue, right? It's in unnecessary stored in many places. Effort wise, high. And like you guys said, integrity. You can't trust the data. So manual error, if manual error happens, you can't tell a problem in the system. So what they did, this was the approach in initial days, and they found a solution for this approach. And the solution was this. It's called centralized database approach. In centralized database approach, what they did, they combined all they combined they combined the complete three database to one database. This one. Okay, the complete all applicant, the payroll, HR, and medical were joined together so that we don't have data redundancy issue. So the data is not repeating now, and it is only in one place. So maintenance is also easy. You need not change in multiple places. Okay. So if you delete, it is going to be in only one place. You are going to delete only one row or one record, whatever. So this was the approach they came. It came into existence in 1960s. And is there any problem in this approach? So we have payroll, HR, and medical together. Is there any issue in this approach? So data is not hidden, or for example, in DB2, we used to have a view, right? We can create views of database so that a part of the database can be given to a particular department because a department should see or maintain only what is relevant to that application, not what is irrelevant. I mean, people in finance should not see what allergy or what treatment someone is undergoing. That is violation. Similarly, a person in medical department should not know what is the salary or bonus they are going to get. So what is an issue here? We have an issue of data security. Okay, we have an issue of data security. Even though data redundancy is not there, okay, data redundancy is not there, and data can be, and hence data integrity also is better because it's in one place. But we have an issue of data security. So then this approach also failed. Okay, earlier it was this approach where we have a dedicated database or a file for every department, and we had an issue of data redundancy and again data integrity. Then they came into a new approach, which is centralized database approach, and this also failed because of data security. Then what they did normalization. Normalization means bringing all the common fields. Okay, bringing all the common fields. So these are three common fields, right, into one group, and they create a relation between the groups. That's called normalization, removing redundancy. Just here, in normalization process, okay, so you are organizing logically related fields into non-redundant groups, and they formed a database, and this was the database. Okay, they brought all three fields which are common to each department as a separate group. Then they establish relationships like this. Don't worry about or how data is going to get stored in IMS DB because we haven't seen at all. You understand? It's very common when I show this slide, people will start thinking how data is going to get stored, how relation is going to get established, etc. Okay, and that is you should not think about that. Okay, that is going to be in future. We are going to tell. I mean, I'm going to tell about how data is going to stored very clearly. But now, from this approach, you can very well see how this approach came into existence. They brought all the common fields together and formed a group and established relationship, and they call this database as IMS DB. It's a hierarchical structure database, or we can say it's an inverted tree structure where we have if you invert a tree, what comes to the top? If you invert a tree, root comes to the top, and we have many branches, and it is based on parent-child relationship. So in this, we have data. So if suppose if medical department wanted to access the data in database, they gave access to this group and this group alone. Okay. If HR department wants to access the database, they gave access to the first group and the last group. But first group is by default. Okay, by default, we have to start from the top. Similarly, a payroll, this group and this group. So we don't have data redundancy because we have removed all the redundant fields and formed as a single group. We have established relationship. Now we have data security also because we can give access to a specific group, whatever they're supposed to access and maintain. So this is how IMS DB came into existence. Any questions till now? So don't think about how data is going to store. Okay, we'll see that. It's very easy. Okay, some advantage of database over files, as already are aware. So if you want to see the database advantages, data redundancy. So data is not repeating. If data is repeating like how it repeats in file management system, we are going to have a space issue. We're going to have data integrity issue. We can't trust the data, and we have other issues as well. Okay, like effort maintenance also is very tough. And again, if plenty of people, when you're sharing the data for plenty of people at the same time, the locking issue also will come into picture. Okay, we can't share the data to plenty of people at the same time. For example, in today's world, if you take say Amazon or if you take Flipkart or it could be any other application, say Facebook, many people are accessing the same data at the same time. Okay, so it's very tough to have data integrity, especially in file management system. Database is much better because of locking. Okay, locking. It locks the data such that only one person can edit the data. Other people can just read the data. So what is data independence? Can anyone say what is data independence? So data independence. So why do we need a database? So data redundancy is one advantage of having a database, and data independence is the second advantage of having a database. Suppose if you take a VSAM file, okay, take a VSAM file used in a program. Assume it's a 80 bytes file. Okay, so it's an 80 bytes file. If you want to add a couple of additional fields, you want a filler, and increasing the length to 100 bytes. So if you are going to increase the length to 100 bytes, what are you supposed to do? Do we need to change the program or not?
Yeah, change the program.
Yeah.
Okay, you are going to change the program in record length. You are going to add your structure is going to be different. If it's a PS file, you'll be changing the program and JCL also. If it's an output file, you have to change the LRECL, block size, etc. Right? So what's happening? So a program is dependent on the data. Okay, a program is dependent on the structure of data. Okay, and format. If it's a fixed format or a variable format, for example. Okay, so structure means length. The program is dependent on structure and format. That's called in data dependence. Okay, program is dependent on structure and format of file management system. Take a database. Okay, it could be a DB2 or IMS DB or IDMS. Okay, if you want to add a column or remove a column, add whatever segment we used to call a segment here, or remove segment, it need not change the program unless you are going to use the column. Okay, if you are going to use the column, you change the program in such a way you can use the newly added column. Otherwise, you need not change the program at all. Okay, that's called data independence. In database, if you are using database, the program is independent of the structure and format of database. Okay, we'll come to data security later. Okay, to something but since you are aware of DB2, how data security is maintained in DB2, you're already aware, right? First of all, we can maintain data security using RACUP. We have RACUP to top secret, etc. Resource access control facility. Using Rackup, we can maintain data security. Second, for database, we can give grant access. Okay, we can give grant and revoke. And third important thing is view access. Okay, we can give view. Through view, data security can be maintained. We can decide who should see what. Okay, through views. Forget about grant and revoke, but through views, we can decide who's supposed to see which columns. Okay, and data locks. Okay, data locks is a very big topic. Okay, data locks is a very big topic. It's not part of this training. If time permits, I'll let you know. Okay, there are different levels of blocking mechanism of database, and based on the locks, data integrity, concurrency, consistency is going to be maintained. Make database make sure it's logged properly. For example, if you are going to book a ticket in any any ticketing app, Make My Trip or any other app, it's maintaining the data logs. If you're going to book a movie ticket in, say, in India and Book My Show, again, data logs are maintained. The data logs are maintained in any database. Okay, database that maintains these three. Okay. Consistency means whenever you see the data, it shows correct data. It will not show incorrect data. That's called consistency. Remember, a database is accessed by thousands of people or few lakhs of people at the same time, or millions of people at the same time. Then consistency should be maintained. For example, assume this time iPhone is launched. Okay, iPhone 16. Okay, iPhone 16 they are going to launch, for example, in September. They are saying in Flipkart, okay, at 10 a.m. we'll start to give 10,000 phones. So at 10,000 rupees. The actual cost is 1 lakh. Okay, so they're giving 90% discount. So how many people are going to log on to Flipkart or Amazon? It could be at least 1 million people. 1 million people are going to buy this 10,000 phones. They are 1,000 phones. Think about the number of transactions. That's so concurrency. Concurrency means many people are trying to access at the same time. That's called concurrency. And again, it should show proper data. System should not hang. System should show, okay, now we have 900 phones available, now 100 phones, etc. So you can trust the data if you have, if you have data locks. Data locks will make sure data integrity is maintained. For example, if you take DB2, or we have some basic locking, okay, page locking modes. I don't know whether you heard about yes lock, U lock. You would have heard about cursor stability, repeatable read, uncommitted read, etc. Okay, and commit and acquire. If in bind process we give acquire and release. So all these together will maintain the logs. Okay, maintain the logs in such a way when someone is trying to update, others cannot read. When someone is trying to update, it's like single write or multiple read. So this is a high level of data integrity. Either one person can write, at that time no one should read. Okay? But if no one is writing, any number of people can read. And all these locking will happen when someone is trying to change or delete. Okay, for insert and if you're going to insert, you're inserting for the first time. If you're going to read, doesn't matter. Anyone can read. But someone is trying to change or delete. At that time, locking will come into existence and it will maintain the data integrity. It's such that either one person can write or plenty of people can read at the same time. Okay, and we have logging functionality. Data logging is also proper so that it is recovered. For example, here we are sending money from GPay through GPay from one person to another person. If anything happens, it's going to be reversed immediately. So everything is proper logging. So all these are some part of advantage of database. If you take a VSAM file, if you give access to a VSAM file, okay, a VSAM file, assume it has 2000 bytes. If you either you can browse or edit or view. Okay. If you open the file, you can see all 1,000 bytes, right? But if you in DB2 or even IMS DB, we can limit the access. How to limit the access in DB2? By view. So we can say who should view which column. Okay, you need not give access to the entire table. Instead, you can create a view and give access to the view for that particular department. So these are some advantage of database. I just thought of saying, so it's one or two things you would might have learned today on. Okay, if you haven't learned anything in database as in a new topic, doesn't matter. See, data logging means whenever you do changes to a database or edit or delete something, generally log should or even insert also. When you do some activity, we call it insertion activity. Just hold on. Whenever you do updating activity, or the log will be maintained by the system. Okay, we have a log file in online. The log file will be in online. The log file will have, say, a program or transaction, okay, or transaction details and date or timestamp, etc. And it will have what was the before image and after image. Okay, what they are trying to do, whether you are going to change or you are going to add something or delete something, it's going to maintain the image copies of the data. Through this logging, logging is primarily used for recovering the data. For example, suppose you are in IRCTC. For example, you are booking a ticket. Okay, IRCTC. So first you are seeing your source and destination and of a train, and then you are booking a ticket. Assume first thing it's creating say PNR database. Assume that we have a database called PNR database. Okay, say customer transaction history database, transaction or we call as transaction database, and we have train database also, and then say payment collection database. Okay. And of course, payment might be coming from say your bank. Okay, that's out of scope of IRCTC. So what here it does in PNR database, it add a new entry, right? Similar transaction database, transaction history database, add a new entry about the transaction. This is for customer. Train database for that day, that train, it is going to reduce the number of tickets. It's going to change. It's going to reduce the number of tickets. It's going to change the existing entry in the row. Payment database, okay, it could be a new entry for the customer. The transaction database is a customer transaction. Payment database, okay, is a customer payment database. So when it's going to add an entry here, it'll just before it is going to add the image copy. Before adding this, for this insert record, okay, there is no image copy because you are inserting for the first time. Whatever your changes activity you are doing against database, it will be logged. Okay, it will be logged. So when you are going to add before adding, you're going to add some transaction in the PNR database. What was the image copy? Nothing, because you are inserting for the first time, and we have some data. Okay, suppose you are trying to when it is created PNR. Okay, it has been assumed this database is PNR. Okay, PNR database, it has added an entry. Okay, assume it has created a PNR. Now customer transaction also, it has added some data. For example, there is no image copy. Okay, and it has changed. It has reduced the number of tickets also in train database. For example, reduce means we have some data in before. Suppose we have 10 tickets and we have booked 2 tickets. For the in new data, it will have 8 tickets. Okay, we have image copy because it's a change transaction. This is going to be changed. Remaining these are add. Okay. Suppose assume we have the customer payment here it failed. Okay, it failed. What's going to happen? When it fails, we'll be having a rollback. Okay, there'll be a rollback implicit. Okay, so rollback. How rollback is going to happen? Based on the log file. Okay, rollback is going to happen based on log file. So what it does, it is going to see what is the image copy and the transaction. So it's going to apply reverse. So here it is change means it's going to change from 8 to 10 again. And see, here it is insertion means it's going to delete the record, delete the record. Okay, I'm just directly gave an example for how a log file will be used. The log files will be maintained in any online application. Okay, in any in software technology, even log files will be used in batch also to some extent. Okay, if required. Only for example in IMS DB it maintains a log file in batch also. Okay, in DLI mode. Okay, DLI mode. I'll tell you what is DLI later. In DLI mode, which is an offline, which is going to process an offline database. I mean, if you want to maintain a log file, you can maintain. So primarily it is used for recovering the data. And these log files are maintained by administrators, the database administrator. And in online, it is going to be automatic. Suppose there is no rollback. Okay, there is no everything is successful. For example, assume we have it's a successful transaction. Program name, timestamp, database, uh, what they are doing, at when they are doing, customer payment, say add. Okay, there is no image copy before, and then okay, image copy. Assume everything is successful, and then an implicit commit will be given. Okay, if it is CACS, a sync point will be given implicitly. Okay, when so this complete transaction is called a logical unit of work. Okay, LUW. That's what people call us in online. LUW, logical unit of work. The complete work is done only if all these are successful. Okay, you can't say after executing, I mean, adding these two database with some data, the work is done. Work is done only if all these are completed. If you, otherwise there will be partial updates. Okay. When how do you know how to commit explicitly? Explicitly means I mean when go back is or return is given, okay, it will do implicitly. When go back or return, system will do implicitly. And go back and return are the last commands to be executed. So when say implicitly means one commit is given, what it is going to do? It is going to remove all these. There is no point of having the log data. Okay. But if it rollback is given, it is going to roll back based on what was there in the log file, the before image copy, and then it's going to roll back. Then it removes the log data. Okay. Once it is rolled back, after rolling back or everything, this is what happens when you are going to uh, debit money in an ATM. Okay. So whenever something happens, it physically changes in the database. It doesn't mean it logically, it physically changes. It adds a data physically. Okay. And again, it will physically remove if there's a rollback. So when we debit, when we go to ATM and debit something, withdraw some money, okay, it first deletes the debits. It creates a transaction. It changes the transaction, okay, in the database, and we get a message. Okay, it got 1,000 rupees debited as a SMS. Suppose it gets stuck in the middle. The transaction is not LU. I mean, the work is not done. The work is done only if the cash is coming out of the machine. If the work is not done, if it gets stuck, what's going to happen? It's based on the log file. It's going to reverse everything. Now it's going to reverse the based on the image count. How it knows without log file? Without log file, it doesn't know. and everything is automatic. If you have multiple application, there'll be multiple log files. For example, IRCTC, they're paying, say, through a GPay, and again, GPay is accessing your ICICI account. There are three companies involved. There'll be three different log files maintained by individually. There may be some MOU or collaboration. Sometimes they'll be working, executing a bad job. Okay, there may be manual verification also. Okay, that will take some time. That's the reason. Sometimes it will take 3 to 5 day working days or 5 to 7 working days to get back the last amount. So this is all about log file. So log file is used for recovery features, and this is maintained by administrators, either database DB2 administrators or IMS DBAs or IDMS DBAs. I don't know whether we have IDMS DBAs. Okay, IDMS very last least used. So DBAs will maintain the log files. Okay, and system will use automatically. That's all automatic recovery feature. Okay, offers online transaction processing platform. If automatic recovery is not available, okay, which most of the software is having, then it's going to be manual recovery by executing batch program. Okay, now let us see the need for IMS DB. Okay, we just saw the structure, need for a hierarchical structure. What is the need? So let's see what is the need. It's very easy, okay, to understand. For example, we saw the structure, need for a hierarchical structure. If you take hospital, so we have patient. Patient is the customer for hospital. This patient is going to come for how many times to the same hospital? Say if it's an Apollo hospital. Apollo hospital is a very famous hospital. Okay, I'll assume Apollo is nearby to your home. So you are going to visit the hospital whenever you are ill. Okay. Okay. So patient can be ill. Okay, for every illness, patient can come and get treatment. Okay, and for every treatment, they are going to get some medicine, etc. So you are going to for every patient. Okay, it's going to be a single patient record with a unique, say, patient number as a primary key. The same patient is going to come how many times? As many times till the end of his life. Okay, to the assume the hospital is his favorite hospital, is her favorite hospital, that's nearby. Whenever he or she is going to get ill, they can come to the same hospital, and every time they are going to get some treatment. Okay, you can have millions of records. Now itself we can say scalability. There is no issue at all. The same patient is going to come as many times. If you take an airlines, okay, a flight number. The flight can fly on a particular day more than once also. Same flight, okay, I mean for that particular day, it can go to multiple places, and for every day it's going to fly. Okay, it's going to fly on every day. The same flight number. Similarly, telecom, one mobile phone you are going to use every day on daily basis. So this is one single record or single entry. There is plenty of entries at the bottom. So in one day also you can have multiple source and destination. And we'll see the structure very easy. It's going to be very easy. Similarly, take a video cassette rental. That's what I'm going to use for our training purpose. A video cassette. A video in olden days they used to give video cassette for rental. Now we are getting rental virtually. Okay, we are getting a soft copy through online, the OTT apps. So we can rent. If it's physical, it's going to be rented only one person can rent at one point of time. So how many people? If it's there's a movie, okay, in older days, Enter the Dragon, for example. So it can be rented by one person. Then it can be rented by another person. So many people can rent the same movie. So that makes hierarchical structure an essential structure. So that's the reason they devised the structure at that point of time. Okay. Now let us learn more on hierarchical structure. So you can see an inverted tree structure and hierarchical structure of a very powerful family in India. Okay, let's see. Let's try to learn some terminology out of this structure. See what was terminology which was used here, used in IMS DB. That's the reason I have this diagram. Probably I'll ask you a few questions. Okay, which is at the top of this structure? Of course, Hirachand Govardhan Das Ambani, right? At the top. So can you see parent-child relationship? See parent-child. How many levels are there in this structure? Four. Okay, we have one, two. This is one level and four level. Four generations. Every generation is one level. So what do you call these two people as? What is the relation between these two people? Siblings. Okay, sibling is the relation. What about the the relation between these three people and Mukesh? They are parent child. Okay, this is parent child. One silly question. Okay, can Akash have two parents? No, only one parent. Okay, one parent for a single child. For every child, there's only one parent. So here you can see a parent-child relationship, multiple levels. It's in a hierarchical or inverted tree structure. Okay, and we saw these two are siblings, and we have parent-child, and one child cannot have more than one parent. Okay, same exactly same terminology we are going to use for IMSD. We are not going to use any other new terminology. Whatever we are aware, we are going to use. Okay, we here every group we call a segment. Okay, we'll call every group as a segment. We'll see slowly. Okay, the first two classes I'll take theory. Okay, to make sure to understand the fundamentals of IMS DB. Then third class onwards, I'll start writing programs. Okay, we'll be first creating a database, and you will also creating database. I'll create and show, and then I'll give some exercise. Probably I'll just give an exercise on video rental. I'll be giving exercise on hospital. So you can do the hospital. You can create database of hospital. You can write programs. At least you can write 15, 20 programs in the totally in the entire training. Now let's move on to the okay. So this is a diagram we have seen earlier. After now normalization process, we have groups. So now you can tell me. So this is a IMS DB. Okay. So this is one group, and we have three groups. So it's related using by parent-child relationship. Okay. So what is the what is the relation between these two groups? We just saw sibling. Very good. Okay. Okay. So now I came to the next slide. Now you see every group is called a segment. Okay, every group is called a segment, and this is a common segment for every group. Okay, so we usually design the structure like this. Okay, we usually design the structure in projects like this. So we'll be designing segment name, and we'll be having the different levels. Okay, when you are designing a structure, the maximum levels you can have is 15 levels. Okay, you can have maximum 15 levels in a IMS DB. Okay, and this is one segment, this is second segment, and this is third segment, this is fourth segment. Likewise, you can have 255 segments in a database. 255 is a huge number, and there is no restriction of how many segments you need to have in any level. And but of course, the segment in level one will be having one segment in level one, only one segment. Okay, so so if you take a traditional file system, okay, assume as a big record. Okay, in the big record is split into partial record. Or we can say it's a part record. This is one small record, a part of a record, part of a record, part of a record, again part of a record. So what do we mean by segment? A segment is nothing but a group of elements or fields. So a segment is nothing but group of elements or fields. So you can say it's a part of a record. How data is going to get stored, we'll see soon. Okay, I don't know we have time today, but we'll be having class till say 9:50. Okay, so we'll make sure. Otherwise, in the next class, we'll be definitely designing a database. Then we can, I mean, I'll tell you how data is stored in IMS DB. Then the clarity will be much better. So we are looking at hierarchical structure. In a hierarchical structure, every group is called a segment. So we can have maximum 15 levels in a hierarchical structure. And what is a segment? A segment is nothing but a part of a record or a group consists of group of fields. And data in the segment is called segment occurrence. That will come to the later. Okay, data in the segment is called segment occurrence. First, in the training, we'll be designing a database, a small database, and then I'll load the data in the database. Then you'll understand much better how data is going to be loaded into the system. Okay, let me ask some questions. So here, so this is level 1, this is level 2, and level 3. Okay, totally we can have how many segments? 255 segments in an IMS DB. We can have maximum of 15 levels. So when you invert a tree, what comes to the top? A root comes to the top. So segment at the top of the hierarchical level is called a root segment. Okay, a segment at the top of the hierarchical level is called root segment, and every segment is a part of a record. Every segment is a part of a record, consists of one or more element. And segment in the same level, okay, segment in the same level are called sibling. And this hierarchical structure is designed based on parent-child relationship. Okay, so this is a hierarchical structure, an inverted tree structure. Segment at the top of the hierarchical level is called root segment, and the second level onwards, you can have as many segments in the same level. Maximum number of segments you can have in the entire database is 255 segments, which itself is a huge number. In fact, I'll just tell you one thing. One segment can be compared to one table in a DB2. So every segment can be compared to a table. Then think about how much columns data you can have, data fields you can have in a database. Yes, you can have maximum 1,000 fields in the entire database. So you can see some definition. A root is the first segment on the top of the hierarchical structure. Okay. All segments below root is or dependent segments. I can see a parent-child relationship. One child will have only one parent. Okay. So these are the maximum number: 15 levels, 2 segments, 1,000 fields. 1,000 fields itself is more than enough. Okay. Beyond 1,000 fields is very difficult to make. In fact, people will never go beyond 25 or 50, 35 fields in a single DB. Okay, so we just saw about the hierarchical structure. Okay, what we did so far is, so we learned about, okay, the data oriented architecture. Okay, like how application oriented architecture, and then centralized database and normalization. Okay, normalization of and how they brought the IMSD. Then we learned about hierarchical structure and the terminologies. Okay, so terminologies are very important. So why hierarchical structure? Terminologies like So we call like root segment, siblings, okay, parent child relationship, dependent segment, etc. So which is an independent segment? It's an easy question. Which is an independent segment in an IMS DB? Okay, now I'll ask some questions. Again, I generally doesn't go to the technical part immediately, okay? Because unless you understand the fundamentals, you cannot learn very easily. So we have some questions. So just forget about the hierarchical structure, etc. What we are going to see, how database is going to contain data, etc. That we'll see later. We'll have some. I'll ask some questions. So assume that we have a tree, or I mean, just say mangoes, or assume the balls are hanging. Every ball has a number. Suppose we have a rule. We have to get all the balls once, and we have to follow a rule top to down. So we have to come top to down and left to right. That's the rule. Okay, top down and left to right. And you have to pick all the balls only once. And you should go in only forward direction. Okay, we should not go in reverse direction. No reverse direction. Reverse direction is not allowed. So you have to pick all the balls once from top down, left to right. You should go in forward direction. You cannot go in reverse direction. If that is the case, can you tell me the sequence in which you are going to get the balls? So 1, 2, 3, 4, 5. Think about the ball game. Okay. Now it is little complex. Remember, left to right, forward direction, no reverse. Okay. You cannot go in reverse. Okay. You have to start from top and then left to right. Now tell me the numbers. But we have one mistake. Can you find? I mean, that person I'm not agreeing. So why not this? Yeah, this I'm trying to pick the ball here. I cannot go back. Okay, that's correct. So you're coming down and you're saying 1 to 8, then going up and 3 and 9. Okay, and this is correct. Assume, see, this is attached to these three. This is separate. Now tell me, you're going to select the box. Which box you select in which sequence? Assume this is first. You have to follow the rule. Top down, left, right. Okay, these three are attached. The boxes are attached to this. Since these three are attached, you have to come here, complete this, then you go here. Okay, as a rule, you have to come top down, left to right. This is in, but you cannot go in reverse direction. Okay, at least you can try. Assume there are, back to back. Now, which one will start? First, we'll start from item one. Then payment to finance one. Item two. Okay, so here I'll ask one easy question. Assume every box is segment occurrence. What is segment occurrence? The data in the segment is called segment occurrence. How many segment occurrences are there in this? 15. Okay, because I already gave the answer is there. Probably will design a database. Okay, now you can just tell the sequence fine, quickly, and then we'll show some. I'll show some examples. Assume A1. Basically, see if you have told this all these correctly, then IMS DB is going to be very easy. Okay, especially when you told all three of you told this correctly, IMS DB is going to be much easier. One thing is it's a complex structure. Okay, so if you know how the structure was designed, then it's going to be much easier. Let me open one this file. So suppose we want to design a database. Okay, what are the conditions you have? Can have maximum 15 levels, 255 segments, and 1000 fields. And what is a segment? A segment is nothing what is consists of. It's a part of a record. It consists of more than one field. Okay, so here we have designed a database where this is one segment, second, third, fourth, and five. Patient segment consists of three fields: patient number, name, and address. Illness segment consists of illness date, disease name. For every illness, there are treatment and billing and pay household. So now I'll tell you some important rules which I didn't tell you. Okay, for example, there are some rules in IMS DB. Rules are okay. A record, okay, a database record consists of one root segment and all its children. A single database record consists of one root segment and all its children. Okay, I'll complete, then you can ask me questions. A child segment can be 0 to many. Many means it could be millions and billions also. I haven't seen more than thousands. Okay. A child segment can be 0 to many. What does it mean? 0 means what? A child segment is optional. Okay. So this is a different structure altogether. If you take a PS file or a VSAM file, what is one record? One record is data in, say, in one line, okay, as a simple definition in single line. What about DB2? One row is in is data contained in single line. What about IMS DB? It's a complete different structure. Okay, the structure is based on the child can be 0 to many. Okay, so this is how IMS DB will have. These are main important rules. A database record is nothing but one root segment and all its children. And the child segment is optional, and each child segment, okay, so I'll write like this, optional. Yeah. Okay, child segment is optional. Each child segment can have any number of occurrences. Segment occurrences. If you have to know these three rules. What is a segment? A segment is a part of a record. If you take a record in a file or row in a database, it's a part of the record. What is occurrence? Segment occurrence. Data in the segment is called segment occurrence. So if you take this rule, okay, if you take this rule, suppose we have one patient. Okay, root segment is must. Okay, for any record, at least a root segment should be there. What about other segments? Optional. Suppose a patient is coming for one illness. Okay, they'll be getting one treatment. Sometimes for one illness they can give more than one treatment. If it's a big illness, there'll be multiple doctors involved, multiple treatments, and for multiple treatments they'll be having different billing. Household mean who is accompanying the patient. Okay, and a patient can have come, and a patient can have multiple illness also. Every time for based on the date. Today they have some issue. Next month they come with a different issue, and subsequent month a different issue, and so on. So for a single patient, one record is enough. We can have the complete history of the patient in single record. Database is very flexible enough in such a way we can add a lot of data for all the related data in a single record very easily. So that's a beauty of design of IMS DB. Okay, in IMS DB, you can add and maintain data of a single, primary key, okay, from start to end for as many years. Okay, let me. So here, okay, I'll just come here. Before that, okay, I'll ask some questions. I think I have some questions here. Questions are not there. So, which is the parent of treatment? It's a very simple question. Illness. What about the child of billing?
No
No child. Very good. And how many occurrences household segment can have? How many occurrences an household segment can have? In fact, answer is any. The answer is any. Is illness segment mandatory? So can you have treatment without illness? We can't have it. Unless a parent is there, child cannot be there. Right? Yeah, treatment cannot be there without illness. Right? There should be some illness, then only we can have treatment. But see, it depends on, all these are optional. Okay, all these are optional. Depends on what they create. For example, a customer or a patient is coming to a hospital with some illness. Okay, in the reception they're creating a patient record. Assume they didn't ask for the illness at all. They're saying doctor is not available, you come tomorrow. Tomorrow we'll add the illness because illness the date is which they can have tomorrow. For example, they would have created a file and they would have given a hard copy file. If only patient number, they would have asked to come tomorrow. Again, it depends. Or they could have added the illness also, but treatment will not be there because all doctors are not, no doctor is available at that point of time. So billing will not be there. Household can be there because someone is assisting. Okay. Again, what I'm saying is it's highly flexible. Okay, it's highly flexible. Let's see some record. Okay, this is not exact representation, but to some extent it's okay. So here, assume patient is 5 bytes and the name is say 20 bytes and address is 40. We'll design a database and show you. Okay, we can give the data type and length. It's very simple. Okay, so assume so here in a patient was here 10,000. Santosh is a patient. He has come with a illness called quinine and Ajimon has created. I mean, is a doctor who treated Santosh. And the billed amount, the amount billed by the hospital and how much amount he has paid. And Praveen has accompanied Santosh. If you see Surya has come with fever. Okay, on 13th January, Ajimon treated. Again, 15th January he came again with corona now. Now, Sri Kumar is the doctor who treated Surya. For fever, they charge 1,000 and he has paid 1,000. And for actually this will be different. Okay, different. I cannot represent easily in an Excel sheet. Probably I'll draw and show you because in the next class we'll be designing a database. That I will understand much more better. And we can have multiple illness for the same patient. So it's has come with corona and Sri Kumar has treated, paid something. Okay, if you see Vijay has came with cough and Yesudas and corona, no doctor was available. Okay, so no billing and payment also. If you take Anushka, she came with body pain, so no doctor is available and no billing, no payment, and then household. So it's highly flexible. This database is highly flexible, where you can have a child as an optional occurrence, and that be many occurrence, more than one occurrence in a child. And the record consists of one root and all its children. Okay, let me see what's the slide I have. Let me open another database and show you. Cannot. This one I don't want to show you now. Okay, I think this is enough for today. So basically, today what we have seen, we saw. What is evolution of the database? Okay, from 50s to 60s, and then different approaches, and then what is the centralized database approach, normalization. We saw advantages of a database to some extent, a need for an IMS DB because one patient can come as many times. Okay, zero to many, again zero to many, and all data can be in single database. Okay, and we saw some hierarchical structure. What are the different terminologies? And then we saw terminology called segment and segment occurrence, or segment type and segment occurrence. Segment type consists of nothing but a part of a record that is of more than one field. and segment occurrence is the data in the segment. Okay, we didn't look at access method that we'll see later. We saw some hierarchical structure on other terminologies. Okay, now we'll probably will you can guess this. How many database records are there in this diagram? How many DB records are there in this diagram? It's an easy question. What is a DB record? One root and all its children
I think one.
in the diagram. So this is one record, one root and all its children. How many children? 14 children or 13 children. What about this? It has only root, no children at all. Okay, it has only root, no children at all. It's possible, right? Children is optional. Children is not mandatory. So totally 2 DB records. Okay, now try to answer this second question. How many segment types are there? It's quite difficult to answer. By seeing this, can you guess how many segment types are there? This is one segment type. Okay, this is one of the segment type. Assume this is one segment type, and this is one segment type. This is one segment type. I think you got the right answer. This is one segment type. We have totally 6. In fact, 8 I think. This is one segment type. Quite difficult because sometimes people will miss this. We'll see the other answers, then we'll know. Just hold on. I'll show the other slide. Okay, tell me how many segment types are there in this diagram. Because we have segment types already mentioned.
5.
Item is one segment type. Renter is one segment type. Payment is one segment type. Status is one segment type. Finance is one. So here item is one segment type. Renter, finance, payment.
4.
Okay, here you can see the second. This is one record. Okay, one record consists of one root and all its children. Okay, this second record. Here there is no payment at all. Okay, there is no payment at all for renter. There is only one renter. You can have as many renter and finance as possible. Quickly, we'll create one small database. Okay, just I will just show you so that you'll understand much better. Probably I'll add some 2-3 records and show. In the next class, we'll create this database itself with the system. The video database. First, let's start with at least a small database with 2 segments. Okay, I don't want to have big database as of now. Let's have a small database with 2 segments. Okay, we'll have a rental and renter. Okay, if you're going to rent a movie, what are the fields you are going? It can contain movie ID, then Like charges, what are you said? Then no, no, return date will just have it and renter. So we have a language, okay, movie name, a language and type of the movie also. Okay, for example, a renter. Renter could be renter name. Okay, then we'll have say uh, renter details, phone number, something like that. And then when they got the, I mean, received date, okay, and return date, and payment made or not, payment done, yes or no, how much they are paid, part payment, etc. So we can have these fields as a part of the segment. So this is one segment, this is one segment, and both are related. And this segment consists of five fields, and this segment consists of these. So we can have data types as character, we can have packed decimal, or we can have a numeric. Okay, assume this is a character when you are going to define database. So in the next class, I will create a database and show you. Okay, I'll create a database and show you. Probably, if time permits, I'll load the database from a PS file also. So movie ID, assume its character, say 04. We can have some okay, some naming convention. It say 20 bytes. As of now, I'll mention character. Charges will be say 3 bytes. Language, not using number for the charges, just as of now for character. The language is going to be say 15 bytes or whatever. We're going to design the database the next class. Just want to tell something. Type, what type? Okay, type of movie I'm just removing. How much? This one will be character. Say 20 bytes. Phone character 10. Date we can have 10 bytes. Say mm/dd/yy something like that. There can be any other data type. Okay, you can design in your own database and payment done yes or no is a flag 1 byte. So here this is how we design a database, and every segment will contain one or more fields. We can use character field or numeric field or packed decimal C, N or P. So anyway we are going to design in the next class. Assume first record, say movie ID. Say some movie ID. So we have some Kalki charges say 100 rupees. It's a new movie. Language say Hindi. Okay, so how many child occurrences we can have? Zero to many. Okay, assume this movie no one has got because it's not released at all. Okay, for example, M02 is Jawan. Okay, 50 rupees. Say Hindi. Okay, say Darshana. I don't know whether the name is correct. Spelling is correct. So Darshana, her number say for example. Okay, received date. So 10th June. She has returned on 12th June. She has paid by Y. Then Ajit is receiving the same movie on say 12. He has not returned, he has not paid. See, there are a lot of ways we can do. Okay. So it's highly flexible database. So we have a third movie. Say some movie. Okay, I'll just write some Tamil movie, for example. Okay, say I'm also okay. So we have assume he has paid, and I got the movie on, but I have not returned, and no, nothing paid. So here you can see this, this is one record, record 1, record 2, record 3. This record contains only root occurrence, no child occurrence. So here root occurrence and 2 child occurrences, and root and 3 child occurrences. So this is how database record will be existing in IMS DB. Okay, and another thing, important thing, I just want to tell you. If you take, say, a file or a DB table, because this is present in main memory, for example, and dash D. So this is in dash D inside permanent storage. Okay, dash D. The program is running. A COBOL program is running, or any language program is running. It's going to read data, or it's going to do all the operations against the file or database, which is in dash D. And it's going to issue some commands: read, write, rewrite, delete, etc. Okay, those are the instructions it's going to give to the machine. At any point of time, how many record it can read? Tell me how many record can read. The read command can read how many records? The read command, one record at a time. Simply write is in this direction. From program to data file, I'll remove. Okay, from program to file. Again, one record at a time. Okay, one record at a time. So this is called a minimum unit of I/O transfer. Of I/O transfer. At any point of time, it can play with or work with only one record at a time. Similarly, for DB2, one row at a time. And for IMS DB, it's going to be the minimum unit of I/O transfer is, or input-output transfer is 1. So one read, you can read only one occurrence. Second read is going to be second occurrence. Third read, third occurrence. Fourth read, fourth occurrence. Similarly, you're going to work only with one occurrence at a time. That's called minimum unit of I/O transfer. Okay. So assume here it's going to be get. Okay, like how we have read, get is the get next is the command function. Okay. The first get is going to get what? Which occurrence in the database?
Root.
This one. Okay, this is first one. Second, now second will be, second the read will be
The child of the root. Leftmost child.
no, this is the first read. First read is going to read. Second read is going to be, so second record. Okay, second record. So this is get next. Okay, this is DB record. How many records we have? 3 records. First get next is going to read this. Second get next, this. Third get next, Darshana. Fourth get next, Ajit. Fifth get next, M003. Sixth get next, Darshana, Ajit, Venkat, and Nilda. So this is how it works. Okay. Anyway, we'll see more. Again, I'm going to design a database properly. I'll create this database in mainframe. I'll be loading the database from a PS file. Okay, you wrote program.